Okay, for the function y equal negative 4 times 3x, 3 exponent 5x plus 1 minus 2, you have to sketch the graph by finding the base function, mapping notation, and TOVs. So I'm going to skip to part B and C and D, and then I'm going to plot it. Find the base function. You can see right away from this function, okay, that the base is y is equal to 3 exponent x. So that's your base function. What is the mapping notation? So before I do the mapping, I'm going to transform this function into the general form of that function which I gave you before. So this becomes negative 4, 3 exponent, 5x plus 1, I'm going to take 5 out, factor it out, so I'm going to get x plus 1 over 5, and then minus 2. Okay? So knowing this one, I can write the mapping function like x and y going to, if you look at this one, we have a 5 here, so it becomes 1 over 5, the reciprocal, okay? And this is plus, the general formula is negative, so this becomes 1 over 5 x minus 1 over 5. Now, for y, you can see that you multiply by negative 4 here, so it becomes negative 4, and then there is a negative 2 here, which is translation down, so it's 4, negative 4y minus 2. This is going to be part C, which is the mapping notation. Now give the table of values for 4 points. It's up to you what points you want to use. I'm going to use the following points: x and y, 0, 1, 2, 3. You can go ahead and find the corresponding y values. Give you one example. For instance, if I say x is 0, then it's going to be 3 exponent 5 times x is 0, so 0 plus 1 over 5 is 1 over 5 times 5 is 5. Is 1. 3 exponent 1 is going to be 3, okay? Oh, I'm sorry. This is the base function that we are doing right now. Sorry. If x is 0, then 3 exponent 0 is 1. If x is 1, 3 exponent 1 is 3, and so forth. 3 exponent 2 and 3 exponent 3. Now for the base function, now we are going to go with the function given here, so xy. Now to do the new function, I'm going to use the mapping notation. This tells me that for every x, I have to multiply by 1 over 5 and then subtract 1 over 5. For the first one, if I multiply 0, this one, by 1 over 5, I get 0, and then it's going to be negative 1 over 5, which is negative 0.2. Then I'm going to have x equal to 1. I put x back here. I get 1 over 5 times 1, which is 1 over 5 minus 1 over 5 gives me 0. If I put x is equal to 2, then I get 2 over 5 minus 1 over 5, which is 1 over 5, which is 0.2. And the last one, 3, so I get 3 over 5 minus 1 over 5, which is 2 over 5, which is 0.4. Now for y coordinate, I'm going to use these values given here, and I'm going to sub it back in this mapping notation here. So if y is 1, I get negative 4 times 1 is negative 4 minus 2, I'm going to get negative 6. Then if y is 3, I'm going to say negative 4 times 3 is negative 12 minus 2 is going to give me negative 14. If y is 9, negative 4 times 9 is negative 36 minus 2 is negative 38. And the last one, 0.4, if I multiply negative 4 by 0.4, subtract, 27 times negative 4, subtract 2 from it, I get negative 110. Now I'm going to use the table of values to plot these functions. So roughly, is going to look something like this. This is my x, this is my y. For the base function, when x is 0, y is 1, which is here. When x is 1, y is 3, it's going to be somewhere around here. When x is 2, y is 9, somewhere around here. So I'm going to get a graph which looks like this. And it goes through this point. Now for the next one, when x is negative 0.2, y is negative 6, so it's going to be somewhere around here, roughly. When x is 0, y is negative 4, which is negative 14, which is going to be somewhere around here. And if x is negative infinity, let's say, when x is negative infinity, then you are going to get y is almost equal to 0. The reason is that if you look at the equation, which is given here, when x goes to negative infinity, 5 times negative infinity is negative infinity, plus 1 is negative infinity, number to exponent negative infinity is 0. So you're going to get negative 4, and this one becomes 0 minus 2. Okay? So this means that when x goes to negative infinity, y gets closer and closer to negative 2, but it doesn't touch or cross negative 2. So this means your graph, if this line is y equal negative 2, your graph goes close to negative 2, but it never crosses negative 2, which is the answer to the last to part E, which says state this equation of asymptote, which is going to be y equal negative 2. In general, the equation of asymptote is this value, this constant, negative 2. Whenever you see that constant, that's going to be your asymptote in general, because the exponent part always goes to 0. Okay? Now, the next question says, state the domain and range. For this function, as you can see, that x from negative infinity to infinity is acceptable. So you are going to say the domain is x in R. But your range values, as you can see, y can only take values which are less than negative 2. So we are going to say that y is R and y is less than or equal to negative 2. Now the last part, it says, is the graph increasing or decreasing? Again, as I said before, start walking from left to right on the graph. As I'm walking along the graph, you can see that x is increasing, but y is decreasing. This means that as x is going up, y is going down, so this means the function is decreasing. Okay? Okay, the next question. You have been given the equation of the base function 3 exponent x, and you're supposed to perform the following transformation. F of x is equal to negative f of 4x minus 7. Then after this one, you have to state the domain range equation of horizontal asymptote. Okay, now the rotation, the transformation is given as negative f of 4x minus 7. So this means that substitute 4x instead of x in this equation, and then subtract 7 from it. So I'm going to have, let's call it g of x after transformation is going to be negative 3 exponent, okay? You change x to 4x, so it becomes negative 3 exponent 4x. Then you subtract 7 from it. This is going to be the equation of the graph. Now, to do domain range and horizontal asymptote, the best way is just to plot the graph roughly. So I'm going to plot this graph. Again, I told you, when you have a constant like this one, this is going to be your asymptote. Okay? So this means that negative 7, y equal negative 7, is going to be your asymptote, something like this one. The only question that you have is that does the graph go over or below this line, which is not hard. So what you are going to do is that, what you can do is that let x go to infinity, plus infinity. If x goes to plus infinity, then 3 exponent 4 times plus infinity becomes 3 exponent infinity, okay? Which is going to be infinity, and then negative infinity minus 7 is going to be negative infinity, okay? So this means that when x goes to negative infinity, okay, what will happen to y? Okay, so to plot this one, what I'm going to do is that I'm going to assign x to go to negative infinity. If x is negative infinity, 4 times negative infinity is negative infinity. 3 exponent negative infinity is 0. Now negative times 0 is 0. 0 minus 7 is negative 7. So this means when x goes to negative infinity, y gets close to negative 7 but never crosses it. When x is 0, 4 times 0 is going to give me 0. 3 exponent 0 is 1. Negative 1 minus 7 is negative 8, which is here. When x goes to infinity, plus infinity, which is on the right-hand side, 4 times infinity is infinity. 3 exponent infinity is infinity. Minus 1 times infinity is minus infinity. Minus 7 is negative infinity. So this means that the graph ends up somewhere around here. So this is my graph. Now that I have the graph, I can easily say what is the state of the domain range and also the equation of horizontal asymptote. You can see that x can go from negative infinity to positive infinity without restriction. So the domain is x in R, and that's it. There is no restriction. For the range, I know that y belongs to the real numbers, but y has to be less than or equal to negative 7. And the equation of the asymptote is y equal to negative 7. Okay, the next question. You have to explain why the equation of 3 exponent negative 2x and f of x is equal to 1 over 9 exponent x are equivalent. And then it is asking you to write the same equations in a different form. So we can simplify the first equation, 3 exponent negative 2x, as 1 over 3 exponent 2x. When you flip the base, the exponent changes sign. This one I can write as 1 over 3 exponent 2, the whole thing exponent x. Remember that 1 exponent x is going to give you 1, so nothing is changed. But 1 over 3 exponent 2 is the same as 1 over 9, so this becomes the same equation. Now, the question is that write another equation that is equivalent to the above two. I can write, for instance, f of x is 3 exponent negative 2x. I can write this one as 1 over 3 exponent 2x. I'm just going to flip it and then change the sign. And you're going to get the same thing. They look different, but they are all the same. Next one. You have the students in a bio class. They observed that the species of bacteria quadrupled in size every 5 hours. On the day they started, the number of bacteria is 10. Create an equation to model the population P and determine the population after 6 hours and 5 days. Okay, so the first one, I know the population is going to be the initial population, which is 10. Now, the factor which is mentioned here is quadrupling, which is 4. Now, every 5 hours, so quadrupling time is 5 hours, so I have to have something like t over 5. Now, t is the number of hours passed, remember. Now, the question is that Oh, it says use the let statement, so I'm going to say let P to be equal to population and T to be number of hours. So this is my equation. Then it says determine the population of bacteria after 6 hours. So I'm going to say P of 6 is 10 times 4 exponent 6 divided by 5. And if you evaluate this one, you get 52.8, which you can say either 52 or 53 bacteria. Part 2 says find the number of bacteria after 5 days. So I'm going to say P of 5 days is equal to 10 times 4 exponent. Now T is hours. So you have to change 5 days to hours, which is going to be 5 times 24 divided by 5. You can easily see that 5 cancels out with 5. And if you simplify this one, then you get a big number, 2.8 times 10 exponent 15 bacteria here. Now, you have a radioactive material with an initial mass of 100 milligram and a half-life of 1.5 days. First, we have to write an equation relating the mass remaining with time. For this part, I know that mass M, which is left, is the initial one, which is 100, times, since we are talking about half-life, so we use 1 over 2. Now the half-life is 1.5 days, again, assuming that I represent T to be number of days, so T divided by 1.5. Graph the function, describe the shape of the graph. So again, we are going to roughly graph the function as, again, when T is 0, then 1 over 2 exponent 0 is 1, so you get 100, so the y-intercept or the m-intercept is 100. When T goes to plus infinity, remember, since the base is less than 1 over 2, when T goes to infinity, then m goes to almost 0, but not crossing t-axis, so it's going to be somewhere around here. And when T goes to negative infinity, then, because again the base is less than 1, then m goes to positive infinity. But again, since we are talking about time, we cannot go to negative infinity, so our graph is going to look something like this one. But the other half of the graph, if you really want to see it, it's going to look something like this. Limit the domain so that the model accurately describes the situation. You can see that the domain is T has to be greater than or equal to 0. So C, the domain, is T in R, and T has to be greater than or equal to 0. Find the amount remaining after 8 days. So I'm going to use the formula, and I'm going to say that dm is 100 times 1 over 2. T is 8 days, so I can just replace T with 8 over 1.5. If you simplify this one, then you are going to get 2.48 milligram. The other one says after 2 weeks, so M is going to be 100, 1 over 2. Now 2 weeks is going to be 2 times 7, which is 14 days. So it's going to be 14 over 1.5. If you evaluate this one, you get something like 0.16 milligram. Now for the last part, how long does it take for the sample to decay to 3% of its original mass, I know that equation is m is equal to 100 times 1 over 2 t divided by 1.5. Now I want to end up with 3% of 100, so it's going to be 0.03 times 100. 3% is the same as 100 times 1 over 2 t over 1.5. You can cancel 100. Now to solve for t, the easiest way is to take the log of both sides. So if I take the log of 0.03, I get log 0.03 is equal to, taking the log of the right hand side, I'm going to bring the exponent down. So it becomes t over 1.5 log of 0.5, 1 over 2. So I say I get t over 1.5 is equal to log of 0.03 divided by log 0.5. Then I multiply both sides by 1.5. I get t is 1.5 log of 0.03 divided by log of 0.5, which is approximately going to give you 7.6 days. Question number 6. You're supposed to solve these exponential equations. The first one, a, as you can see, the bases are the same, so the exponents, they have to be equal. So I can say that 3x exponent 2 plus 4x has to be equal, but 2 exponent 2 plus x minus 2. I'm going to move everything to the left and change the sign. So I get 3x squared minus 2x squared is x squared. 4x minus x is 3x. Minus 2 to the left becomes plus 2 is equal to 0. I can use factoring instead of using quadratic. Two numbers that they multiply, or the product is 2, add up to 3. Those two numbers are 1 and 2, so I can write this one as x plus 1 times x plus 2 is equal to 0. So I get x is negative 1 and x is negative 2. Okay, part B, we have 2 times 3 exponent x minus 2 is equal to 54. I divide both sides by 2. I get rid of 2 here. I get 3 exponent x minus 2 is equal to 54 divided by 2 is 27. 27, I'm going to try to write it as base 3, which is 3 exponent 3. So I'm going to say x minus 2 is equal to 3, so x is equal to 5. Okay, the last one, the rational function, I'm going to express everything in base 3. So I can write 9 exponent 2x minus 1 as 3 exponent 2, and the whole thing 2x minus 1. The next one, I can write this guy as 3 exponent 2 times 3x is going to give me 6x divided by 27. I can write as 3 exponent 3, and then exponent x plus 2, and the whole thing exponent 3. And this guy I can write as 3 exponent 4, and then exponent 3. Now 3 exponent 2, exponent 2x minus 1 is going to give me 3 exponent 2 times 2x minus 1. And then since the bases are the same, I can add the exponent, so I get plus 6x divided by, now this one I can multiply all these numbers, exponents together. I get 3 exponent, 3 times 3 is 9, times x plus 2, which is equal to 3 exponent 12. Now since I'm dividing exponents together, I can just subtract exponents. So from here I get 3 exponent 2 times 2x minus 1 plus 6x minus 9 times x plus 2 is equal to 3 exponent 12. Since the bases are the same, the exponents, they have to be the same. So 2 times 2x minus 1 plus 6x minus 9 times x plus 2 has to be equal to 12. Now, if you distribute 2 inside and 9 inside, negative 9, and you simplify, then you are going to get x is equal to 32. The next one is to simplify these rational fractions based on different variables, x and y. So we start with a, which is given here. So I'm going to just cancel out 3 here. Then I'm going to write the numerator as y exponent 1 over 4 divided by. Now, I have a 4 here. Now I have only x, so I'm going to write x exponent negative 2 over 3. And then y's, because the bases are the same, I can add exponents. So I'm going to get y exponent 3 over 2 plus 1 over 2 is going to give me 4 over 2, which is 2. This is equal to, now I can bring everything, flip the fraction, and just write it as 1 over 4 times y exponent 1 over 4 times x exponent negative 2 over 3 when it's flipped is going to give me x exponent 2 over 3. Y exponent 2 when it's flipped it is going to give me y exponent negative 2. Now, since y's they have the same base, I can add fractions in the exponent. So 1 over 4 minus 2. So let's see what is 1 over 4 minus 2. I can write 2 as multiply by 4 divided by 4. So I get 1 over 4 minus 8 over 4, which is minus 7 over 4. So it's minus 7 over 4 times x exponent 2 over 3. And I can't go any further because x and y are different bases. The next one is b, x exponent 3, y exponent 2, 3 over 2. So before I do anything, I'm going to simplify the numerator. Since I have 3 over 2 here, I'm going to distribute it inside the bracket. So x exponent 3 over 2 is going to give me x exponent 9 over 2 because you multiply exponents. And y exponent 2 times 3 over 2 is going to give me y exponent 3. Because 2 times 3 over 2 is going to give you 3. The next one, I'm going to simplify the denominator. So I'm going to multiply 1 over 4 by negative 1. I get x exponent negative 1 over 4. And negative 2 over 3, I'm going to do it here, negative 2 over 3 times 1 over 4 is going to give me negative 2 over 12, which is negative 1 over 6. So y exponent negative 1 over 6. Now, to simplify this one, I'm going to subtract exponents because we are dealing with division of exponents. So I'm going to have x exponent 9 over 2 minus 1 over 4, which is 1 over 4 addition. Y exponent 3 minus 1 over 6 becomes plus 1 over 6. Now, what is 9 over 2 plus 1 over 4? Again, 9 over 2 plus 1 over 4. I multiply by 2. I get 18 over 4 plus 1 over 4, which is 19 over 4. So it's going to be x exponent 19 over 4. Y exponent 3 plus 1 over 6 is the same as multiply by 6 divide by 6. So I get 18 over 6 plus 1 over 6, which is 19 over 6. Now we are going to do part C. 3x exponent negative 1 over 2, this one. So again, I'm going to simplify all the similar bases. So 3 goes with 3. So I'm going to end up with 3x. And then I can add the exponents negative 1 over 2 plus 1 over 2. And then y exponent negative 1 over 3, because there is no other y in numerator, divided by y exponent negative 7 over 4. Negative 1 over 2 plus 1 over 2 gives you 0. X exponent 0 gives you 1. So this is gone. So you're going to end up with 3. And then I'm going to bring this one in the numerator and change the sign of the exponent. So I get y exponent negative 1 over 3 plus 7 over 4. Remember, you change the sign of the exponent. Now, negative 1 over 3 plus 7 over 4. I use the common denominator of 12. 12 divided by 3 gives you 4. And then you multiply negative 1 by 4, you get negative 4. 12 divided by 4 gives you 3. You multiply 7 by 3, you get 21. Negative 4 plus 21 is 17 over 12. So you get 3y exponent 17 over 12. Okay, now we are going to do D. To do D, I'm going to distribute 4 inside the bracket. So I'm going to multiply every exponent by 4. If I multiply 1 over 2 by 4, I get 2. So I get x exponent 2, y exponent. Negative 2 times 4 gives me negative 8, divided by 4 times negative 7 over 4 gives you negative 7. So you get y exponent 4. Because you have y here, exponent is 1. 1 times 4 gives you 4. And x exponent negative 7 over 4 is going to give you x exponent negative 7. Now I'm going to bring these two bases up, and I'm going to change the sign of the exponent, so it becomes x exponent 2 plus 7, because negative 7 becomes positive 7. Y exponent negative 8, and 4 becomes negative 4. So the answer is x exponent 9, y exponent negative 12. Next question. You buy a brand new boat for $87,000. The cost is $87,000. It depreciates at a rate of 17% per year. How many years will it take for the resale value of the boat to drop to $38,375? So we can write this resale value, let's call it V, is the initial cost, $87,000, times, since it's depreciating, so it's going to be 1 minus, and the depreciation rate is 17%, which is 0.17. 17 divided by 100%. Now, and it says every year, so it's going to be exponent t. Now, this one can be written as 87,000 times 1 minus 0.17 is 0.83 exponent t. Now, I want to know how long would it take the price to drop to 38,375. So V is 38,375. I'm going to divide both sides by 87,000. And I'm going to get 0.83t is equal to 38,375 divided by 87,000. Now, if you take the log of both sides, I get t log 0.83 is equal to log of 38375 divided by 87,000. If you solve this equation for t, you get t is approximately 4.39 years. Okay, the question is that you are depositing a dollar every year, and then after that you are going to double the money. You are right now 16 years old. Assuming that there is no withdrawal from the account, the question is that when can we call you a millionaire? Or when do you expect to become a millionaire? Okay, very simple question. So let's say S represents your saving. The initial value for the saving is $1. Okay, now you are doubling your money, so the base is 2, and every year you are doubling your money. So the doubling period is 1, so you are going to say 2 exponent t. Now I want this S to be $1 million. So as usual, I'm going to take the log of both sides, so I get t log 2 is log $1 million. So I get t is approximately 19.9 years. Since we are asked to see how old are you, you just add 16 plus 19.9. It's about 36 years old. So if you start depositing when you're 16 every year, double the money, by age 36 you are a millionaire.